Welcome to Going Green with Security. I'm the moderator, Elisa Watlington, and today we have Mr. Brian Denmead speaking. He has been with CBC a little over 15 years, and as a field application engineer, he's passionate about AI and surveillance, and he is our tech guru. Take it away, Mr. Brian.
Thank you, Lisa. So we're going to go over quite a bit today. We're going to try to keep it simple, and hopefully my explanations are right on the money and I don't go too far over anyone's head. So with that, there's going to be 4 primary talking points for this webinar, ending with a Q&A session when everything's said and done. And what we're going to try to do is we're going to try to cover AI's role in sustainable security. We're going to try to cover the sustainable features of the CORTROL Solutions platform. We're going to try to cover the 1-2 combo offered by CORTROL and the AI box when used together. And we're going to hopefully round it all off with how enhanced sustainability via IoT integration comes into the picture as well. So what do we mean by sustainability and security? Well, very quickly, we are referring to the carbon footprint of a video surveillance solution. This means the energy consumption, the electronic waste, and resources related to running video surveillance. Why does sustainability matter in a VMS? Well, it's one of the components that, in this case, provides several solutions that help minimize or reduce the carbon footprint of a surveillance solutions platform. In this case, we'll be referencing our CORTROL VMS, which offers several things that impact that. So, AI and sustainability. Note, the future matters now. So AI analytics and energy reduction using CORTROL. So smart energy management. 2 ways that it impacts is in the reduction of false positives and in the reduction of cost. But that's just the icing on the cake, if you will. So reducing false positives means a reduction in the number of times a patrol car on site is needed. This would be one example. This helps reduce emissions as the car is not running or in motion as much. It also reduces the amount of fuel used as the number of potential trips to a location are reduced. So take that times that by the number of patrol cars that a particular deployment may have, and you can quickly see how there's a reduction in costs from gas, from time, from vehicles, from the carbon or CO2 that's put out by the cars. This helps reduce the number of times a guard has to leave their post to investigate. And that's not just from the perspective of getting into a car. In some areas, they're using segways, they're using motorized bicycles. So even in those areas there, you're helping cut down in the energy usage, the cost of that energy, the cost and time that it takes that guard or that police officer to get from point A to point B. And a lot of things can happen in that time. So the absence of that person in the monitoring station or monitoring position has a great impact there as well. So the impact and requirement and the amount of manpower, the amount of equipment and power consumption all add up when everything is said and done. So AI reducing false positives. So how does AI help reduce false positives over the standard stuff? Well, let's try to get into a better understanding of false positives and their usage. So false positives in security surveillance leads to an increase in operational cost and wasted energy by triggering unnecessary deployments of resources and diverting security personnel from real threats. So in other words, a false positive is not considered a real threat. It's a false positive. It's an event that happens that is not specific to the event that you want to be notified of. For argument's sake, a bird going across the front step of a doorway versus a person approaching that doorway. I'd rather know about the person than the bird. The bird is a false positive. The person is a positive event or a something I want to know about. So this not only reduces surveillance efficiency, but also has an adverse environmental impact, contributing to higher carbon emissions and energy consumption, contradicting sustainability objectives. So going back to the police officer or the security guard and using mechanical devices that are powered by electricity or powered by gasoline or diesel, whatever it might be, all of that stuff has an impact on the environment and contributes to a higher carbon emissions because they're in use. Reducing the number of times those vehicles or devices are used reduces the carbon footprint. Energy consumption is reduced, and sustainability objectives, you're that much closer to obtaining them. So, how coordinates unnecessary interventions with precise event detection. Now, using advanced AI algorithms and contextual analysis are two ways where Portugal helps, and we'll dive into that. So, VMS and energy consumption, the role of the video management system in energy usage. Traditional VMS operates primarily on motion-based recording. When motion happens, it's a trigger. It triggers the event and the VMS will start recording from it. There's a lot of, shall we say, extraneous material that gets captured when you're just going from a motion-based trigger system. And part of that is the energy consumption, the storage consumption, or the requirements for high storage, needs significant server resources to manage that energy consumption and manage those storage, not to mention the more powerful CPUs, the larger amounts of memory that would be required to go through the process of detecting the motion, capturing the video in the time frame of the motion, capturing the extraneous information. In other words, false positives could be in there, and then being able to manage and store all that data. That's your traditional VMS. So there's not too much intelligence there. It's more of a reactive system than, say, a proactive or intelligent system. So the cultural VMS provides intelligent identification of the object that is initiating the event. The AI is turning around and saying whether or not the object that is initiating the event is relative or not relative. So what you end up is with a VMS that records only the relevant events. That significantly reduces any unnecessary recording because now you're only recording on the events that are, well, positive versus a false positive. Your storage does not need to be as large in capacity because you're fine tuning how much storage you really need. And that's eliminating extraneous storage requirements, which extra storage, extra power requirements. All of that also helps in your reduction of data processing and of management. So these are all ways of reducing those footprints, the power requirements, and even overhead. So Control's non-re-encoding of H.264 and H.265 streams are one way that Control helps save on efficiency. It helps on power. You don't need to have a processor that is powerful enough to basically reprocess existing video streams. Control is just going to take the video streams in as they are. This provides efficient data handling. It enhances energy efficiency by handling those video streams in their original formats. Again, it doesn't have to re-encode or code them. So resource-intensive processes that require significant power and consequently energy to reprocess or process video aren't required. By avoiding this, Quattro minimizes the workload on your servers. It leads to lower energy consumption because, well, you can utilize a CPU that has a lower power requirement. So that in and of itself allows you to have a server or workstation or a network video recorder that can utilize lower power. Preservation of the original quality. So the method also ensures that the video coming from the devices, its original quality is maintained. You don't experience degradation that happens or potentially happens from re-encoding. If you don't have a hardware platform powerful enough, re-encoding can actually reduce the quality because it just simply doesn't have enough of the resources to properly re-encode. So there's also a downside from that. But in this case, CORTROL ensures high quality surveillance without additional energy expenditure over traditional options or traditional video management systems. So technological features supporting energy efficiency. So different options obviously are going to have different impacts on the footprint. Fisheye dewarping. If one way to look at that is if you're doing it on the client side, the client is actually doing the dewarping of the fisheye. It uses less power than, say, the server side dewarping, where the server is dewarping it there during the reprocessing of the memory, and then relaying it to the client. In this case, the client will utilize the hardware it's on and dewarp the fisheye. More efficient, less power being used on one end. It helps balance out the overall needs. Localized processing. It's a great way of looking at it from the perspective of encoding or re-encoding video. If you have to re-encode the video, you're going to need to utilize that local processing. That local processing can either be a high requirement or a low requirement. CORTROL has a lower CPU or processing requirement over traditional platforms where they don't turn around and will re-encode the video. RTSP video streaming. So RTSP video streaming is a highly efficient format of video streaming. Without getting into all the technical details, its efficiency allows for lower bandwidth requirements and allows for lower power requirements since the networking packet is lower than traditional video streams. That provides bandwidth and storage efficiency as well. So because the video doesn't need to be as high in a bit rate, it doesn't have such a high overhead or footprint as a video stream. It's not impacting the network in a way that an on-viv video stream, which has a lot more data to it, would impact. You end up having better bandwidth control. You're better able to balance the bandwidth control, and your storage efficiency also goes up because, again, you're getting a video stream with very minimal extraneous data attached to it. And when I say extraneous data, I mean metadata, analytics. You may have titling that is embedded into the video stream as opposed to being just burnt into the video stream itself. Other ways that CORTROL can help in this, or other technological features that help in this, is centralized efficiency. CORTROL supports various types of configurations, from a local host centralized processing system to a hybrid where you have part local host and part cloud. And then you can have the whole thing in the cloud. Depending on the configuration and depending on the scale, they have various impacts on the carbon footprint and the requirements in power. Kind of brought together, these things on a whole can have a much greater impact than individually. So the more you can get into the design of the system for power efficiency and performance efficiency and reduction on false positives, the smaller that carbon footprint is going to be. So hardware choices, we're kind of alluding at this as we talk about things that impact the power requirements. So in this case, in comparison, traditional hardware versus modern hardware solutions. Again, we're talking about CPUs that are higher end CPUs versus lower end CPUs, higher end requiring more power. Again, more power, the more or the further away from the goal of sustainability you get. The lower the power requirements, the closer to your sustainability goals you get. So it's fairly straightforward in that regards. But again, what's not straightforward is just knowing how best to bring all the different hardware together. But it's not just going to be a CPU. You get the hard drives. You're getting proper storage and efficiency, so you can use less hard drives or lower powered hard drives. It's all based on how you design the system and keeping in mind the sustainability goals as you design. Okay, so what's one of the components outside of a VMS that we can add to that design we were just referencing? Well, one of them would be the Ganz AI box. It's basically a net appliance, an edge device. It's essentially an IoT device when everything's said and done. But what it does is it brings edge processing for an AI engine that provides various. I think the device is over 35 potential AI analytics that it can deploy. Not that it can deploy all of them at once because it is an embedded device, but it gives you the ability to design with a target analytic in mind without having to have a larger hardware, bigger processors, or memory. It's an embedded device that's been specially designed to be really efficient from a hardware perspective on handling the analytics. So what are some of these things that it does? Well, it helps with the AI with a reduction of false positives. The AI box can effectively decrease false alarms. This can lead to real-time decisions that help reduce the need to deploy patrol cars, personnel, um, false alerts or alarms that might go out that don't need to go out. The mobile alerts that it can send to personnel, to security personnel or administrative personnel, whoever the target person or target group might be, it can send emails to. It can also send alerts that include snapshots, images of the event that allow you to have a quick and immediate verification of, oh, I need to respond to this right now, or you know what, that's not an emergency, but it is something that I have to escalate. And so you can take your time a little bit more with that. Or, you know what, I don't need to respond to that at all. That's an okay scenario. Energy efficiency. So because it's an IoT device, it uses very low power compared to more traditional options. For argument's sake, if you've got a camera with a full-blown AI suite on it, and you're going to utilize 8 to 16 cameras, that's going to be a lot of power. Where the AI box can handle 8 to 16 channels. So you could actually utilize cameras that utilize lower power. They don't have to have AI on them. The box can provide the AI. From a cost perspective of labor, installing, removing, configuring. From the false positives perspective, the AI is acting as that filter between what's a legitimate event and what's a false positive event. This is a box that brings a lot to the table as being a component to a well-designed surveillance system with sustainability, low carbon footprint in mind. So some more benefits. So pairing the AI box with low-powered cameras, as we kind of already talked about, helps reduce the overall energy footprint. So you have an AI box utilizing low power. You're utilizing low power cameras. Your network does not have to be so robust in bandwidth because the amount of data coming across it's going to be smaller. The AI box offers aid to companies in meeting sustainability goals and requirements because of its low power and because it can balance low powered cameras with the network. Again, giving you more pieces of your platform, your solution, utilizing less power, and basically a smarter system, reducing false positives. I think at the end of the day, false positives are probably the biggest waste of energy and time and cost. So, what are some other ways that we can reduce power? Well, let's go back to the CORTROL VMS. So we talked about how a VMS that doesn't need to reprocess video can use lower power hardware. Here's a perfect example. You could deploy CORTROL on what is called a PC stick. It's essentially a computer in the form of a stick that's got a antenna on it. It may have an RJ45 port on the back of it, but it essentially plugs into the HDMI port on the back of a monitor or television. It's a full-blown computer, but it's a low power, low performance platform. And that's not a bad thing. In this case, CORTROL can run on it. It can provide several advantages. With the CORTROL Global, it can offer video walls. With video walls, you can have multiple monitors, multiple PC sticks, and video walls can be everything from traditional command center video walls where you have various layouts on every single monitor. It could be tiled where it's just one image across multiple monitors. You can utilize them for information kiosks, for public display monitors. You can drive a whole scale of small scale camera deployments, all centralized in management and in power reduction. It's going to be an incredibly small footprints. You're talking, you can use a PC stick for a 4 camera system or an 8 or 9 camera system with some localized micro SD storage in that PC stick. And you can use it for recording. So it allows you to have options for lower cost from energy, from that in terms of the cost of purchase, and in terms of the time it takes to install and set up. There's a lot of cost savings there, and a much smaller carbon footprint because of it. So integrating IoT devices, we kind of already touched upon the AI box, which is an IoT device. But what are some of the things that your more traditional IoT devices are bringing to the table? They're bringing continuous monitoring with minimal intervention. They're bringing smart resources and management, enhanced predictive maintenance. So what are we really saying by some of this stuff? So continuous monitoring allows is basically where the devices are, well, just that, continuously monitoring something. And this might be the electricity, this might be temperature control, this may be current water levels or the volume of gas in a container. It could be monitoring weather patterns. IoT devices are essentially very, very smart sensors, and they've got designs for all types of detection mechanisms. Things we touched upon now just being the tip of the iceberg. But the monitoring of various parameters, the composition, pressure, chemical composition, air quality, smart resources or smart resource management of those detection of those sensors, intelligently managing the resources, the sensors themselves, the intelligence behind them. You can add automatically or automatic adjustments. So if the device is intelligent, which most IoT devices are, the water level gets too low, or the metric volume of the gas is either too much or too little. These are all things that the IoT device could potentially automatically adjust. It could also provide, as mentioned, the predictive, oops, let me get my mouse over here. They could also provide enhanced predictive maintenance. And what we're really basically saying is, because it's a pattern, the IoT, and especially if AI is involved with the IoT device, can effectively predict, okay, this device is good for 5,000 cycles. And as it gets closer to 5,000 cycles, things start to wear down. So an AI can turn around monitoring that wear and tear and say, you know what, we're not going to make it to 5,000 cycles. We're going to make it to 4,055 cycles. Here's an alert. You're going to be able to be proactive because of the alert, and you're going to be able to, in a very calm and collective fashion, schedule your maintenance to take care of the device or whatever it is the sensor's monitoring, so that you're not panicking, you're not doing it last minute. The cost savings of being able to take care of something in a calm and collective fashion compared to having to take care of something in a panic, it's a night and day difference about a lot of wasted energy. Some of the other stuff. To the next. So examples of IoT devices integrated with CORTROL. So as we get into that discussion, just consider all the things that IoT devices in and of themselves can do. So in this case, we're providing integration with IoT-enabled locks and biometrics. CORTROL can streamline access control because of its integration with the biometrics and the IoT devices. It can reduce the need for manual oversight because of its events and actions. When prescribed events happen, it can have a mandated response. A notification can be part of that. There's a lot of things that can be part of that, but the system is smart enough to have that you can automate it when all these various functions or options are brought together. The IoT devices are energy efficient. One example, smart cameras, which are basically IoT devices with camera functionality built into them. So integrated with CORTROL to employ analytics that activate recording when suspicious activity is detected. So now the AI on this IoT device, again, we're talking about a camera at the moment, but it could just as easily be a thermostat, a air quality control. Basically, the IoT device will give CORTROL the knock on the door that, hey, there's an event happening and I need you to respond to it. And CORTROL will already have the response pre-programmed. Depending on the simplicity or complexity, the response can be really well thought out, where everything is covered in terms of starting the notification, dialing back valves or channels or electricity or whatever might be needed to try to balance out whatever's going on, whatever it is the IoT device is notifying you about. In the case of air quality control, well, CORTROL could be turning around and opening up vents and turning on blowers. So just some areas where, or some examples of just environmental monitoring from that respect. So because the IoT devices are plugged into all these things, it allows CORTROL to act as that central, basically like a composer, if you will, or a management of all the integrations and when an event happens, what type of reactions to take, who to notify, how to respond. With the IoT devices, we can see a decrease in overall carbon footprint. We can see optimized energy usage because the IoT devices themselves utilize energy very, very efficiently. They're designed to use very little energy. They're very good at reducing physical infrastructure because they are so much smaller, and you don't have to have these big boxes and have them all sit inside the big boxes. You can strategically place them where it makes the most sense, allowing you to optimize whatever space you have. So this helps reduce expensive infrastructure. If you look at a particular data center where all the computers are in the racks, those racks are expensive. Every single computer in those racks take up a certain amount of space, and they themselves have a cost to volume ratio, let alone cost to technology ratio. IoT devices are much more compact. They're basically simplified in the sense that they're designed to do a couple of things really, really well and at a very good cost point, a very good energy usage perspective, a very good deployment perspective, making things easier in the overall scheme of things. That provides sustainable operations and maintenance when things are easy to get to and easy to change and easy to replace or fix or even just address. So CORTROL's built-in functionalities. We already talked about the video wall functionality, the versatility of that video wall, the fact that it's built into CORTROL. It's not something that's an additional function that needs to be purchased. It comes with CORTROL Global. So we're already talking about a cost savings there. I guess when we're talking about carbon footprint, we should be talking about the carbon footprint of not just the energy usage, but the exchange of money, the cost of things. I mean, that's really part of a carbon footprint. You have a very large carbon footprint, you have a very large costs. If you reduce that carbon footprint, you can reduce the general costs and create a sustainable platform. CORTROL's deployable over low-power PC sticks. That falls right in line with the sustainability for various scales of deployments. Events and Actions Manager, as we already discussed, help automate responses so that there's less manual oversight or manual monitoring that's needed to say, okay, you can do this or you can't do this. It's already built in. The AI box, the IoT devices, the lower powered hardware that CORTROL is running on, CORTROL's ability to interact with all this stuff and have the integration there that's basically say, hey, when this happens, I need to do this. And I can do a couple other things on top of that. Again, efficiency. So AI box, when it's power, the AI box is operated off of 12 volts, 3.3 amps. So like we said, it's very low power. It's 16 watts. Compare that to a full-blown server with multiple processors in it and additional memory and storage. And 16 watts is extremely small. Compare that to a server with a video card in it that requires 1,000 watts. I mean, very, very power efficient here. Uh, Designed for high efficiency. I mean, if you talk about 16 watts, yes. The AI box supports 8 channels, up to 4K resolution, 60 frames per second. It can support 16 channels at 1080p or 2 megapixel resolution. It offers real-time processing capabilities that are essentially at the edge. Now, doesn't mean that the AI box has to be literally at the edge where the cameras are. No, it can be hosted locally in a local server room, for argument's sake, because you can bring the video streams to the box. You could also bring the box to the video streams. It's flexibility, it's more efficient logistics and options that are brought to the table by design. CORTROL, well, we already said it utilizes lower or can utilize lower powered components. You don't have to have these big power all consuming configurations in order for it to do the general day-to-day stuff. Performance-wise, it excels at handling large volumes of video data across thousands of channels. It offers advanced analytics, whether the analytics are utilizing ones that are built into the software, into the video management platform, whether you're using the analytics of an external device like the AI box or what you might from cameras or IoT devices. It excels at handling all that stuff. It's well designed for these type of environments where extensive video monitoring and analysis are required. It does a phenomenal job. So let's get a little deeper here. So the AI box is ideal for smaller businesses where a limited number of cameras, up to 16, said 8 to 16, are sufficient. This includes small businesses, retail stores, residential complexes. Small deployments are anything from 8 channels up to 32. And we say 32 because it's 1 to 2 boxes. Medium deployments can be utilized there as well, where you may have up to 96 channels. So you're talking up to 4 AI boxes that might be deployed. Figuratively speaking, you could deploy more. It just becomes a question of managing more than 4 boxes at a time. CORTROL can do it. When you integrate the AI box with CORTROL, you can certainly go beyond 96 channels worth of analytics. CORTROL with CrossLink Basic allows you to access each individual AI box and manage it through CORTROL. Again, centralizing management, reducing labor requirements because everything's literally right there centralized for you to deal with. It's great. Overall, it's great with immediate video analysis and decision making are needed, since it does all the analytics right there and it can immediately respond with sending out a notification based off an event. It's great for organizations that are looking for cost-effective solutions, low energy consumption, because as we said, if we look at a deployment, okay, let's just say you've got 16 cameras that are already deployed. Well, you're looking to add AI to that. Okay, let's take one box, install, configure one box versus sending out a laborer to go and pull down a camera, which may or may not include a truck or a van or a bucket truck for that matter, where they got to go up on full heights to bring the devices down. That's a lot more intensive. We talk about 16 cameras, you can replace all of them. And the cost of the labor, the cost of the materials, the cost of the product versus one box, one location, and maybe 30 minutes, maybe an hour to set the AI box up to requirements versus trying to set up 16 different cameras, installing them, that's going to take days. So there's cost effectiveness all around with this product. CORTROL. Well, as already alluded to when we talk about the AI box going beyond 96 channels, the Control is ideal for large organizations. It's also ideal for smaller ones, but in the scheme of things, it's capable of managing thousands of video streams simultaneously. It's suitable for large enterprises, cities, and complex infrastructures where comprehensive surveillance and extensive data analysis are required. It supports numerous plugins, compatibility with a wide range of third-party systems. I mean, effectively, you're talking over 15,000 devices are supported, beyond over 15,000 devices. I'm going to say it one more time. It supports over 15,000 devices. That's a lot of devices. And it supports from over 190 manufacturers. So it's pretty compliant across platforms, across devices, across use requirements. It's not specific to one brand, one make, one model. It's going to support, figuratively speaking, everything that's out there in one way or another. It offers advanced video analytics capabilities, behavioral analysis, recognition triggers, extensive reporting features. It's essential for environments where detailed insights and proactive security measurements are a necessity. So it's a robust system. So AI box and sustainability. I mean, we're talking a recap here. The AI box allows for low bandwidth requirements. So because it doesn't need to have a very high resolution image for the analytics to do their job, you can utilize lower resolution images. That's lower data in the network. If the network is utilizing lower bandwidth, it's less power that's required. You can companion the lower power cameras and the AI box for even more reduction in power consumption. It offers various low power options for notifications and alerts. You can either have, if you're utilizing the AI box in conjunction with Control could be the one sending out the notifications, or if you're using the AI box as more of a standalone, it can send out the notifications. So its notifications can go to email, they can go to a smartphone, tablet, they can go through a text message where the information may be included. There's a lot of ways it can do a low power communications directly from the box itself. Control's CVA is sustainability. So Control's video analytics, basically what the CVA stands for. You've, in the same way that the AI box can be utilized to retrofit cameras that don't have analytics with analytics from a single point instead of multiple points. Quattro has built-in analytics. Those same analytics can be deployed across cameras that don't currently utilize AI or any analytics for other than maybe motion detection. And with that deployment, again, we can reduce false positives via the analytics. This saves time, it saves labor, it saves cost because now, again, you're not going out to all these cameras and you're not incurring the cost of removing the old, putting up the new, and reconfiguring everything. If you're talking about analytics, you're going to be configuring it either way, but in this case, you've already got probably 60%, 70% of your infrastructure doesn't have to be touched. You go to the control, you activate the licenses, you select your channels, you deploy your AI. One person, one location, reaching out to all the different spots. On top of that, the ability to utilize lower CPU for the general stuff, throw in a video card to accelerate the analytics from simple to complex. And you really have great solutions options for designing systems that are extremely power efficient with intent. Okay, integrating IoT devices. So we already have seen they reduce energy consumption. We already know they're optimized for resource usage. And from that perspective, sustainable operations are just a given. So the decrease in carbon footprint that IoT devices bring to the table over more traditional options is, I mean, it's almost transparent from the ability to monitor energy usage, integrating IoT thermostats with and HVAC systems that allow dynamic temperature control when, again, we're talking an office building or we're talking a school or any type of business where you've got IoT sensors in every room determining what the temperature is, and you're able to set each room centrally to a specific temperature. And the IoT devices will control that versus having to have one big heavy machinery in a corner somewhere which does it all, but costs phenomenally more than the individual IoT devices spread out. Bear in mind, the same IoT devices that are effectively monitoring the temperature could effectively be monitoring the air quality. So you're going to get a lot of mileage devices, much lower carbon footprint. These technologies, AI box, CORTROL VMS, IoT devices, they can all work together to provide a solution, that does provide options for design that provide a synergy and provide for reduction in the carbon footprint, allow you to design with energy efficiency in mind. At the end of the day, the synergy between the three solutions allow you to meet sustainability requirements or sustainability goals in reducing the overall footprint. So, enhance sustainability, efficiency, yeah, between AI box, IoT devices, CORTROL's ability to bring it all together, manage it centrally, and add functions and features on top of everything else really help with an overall reduction in the footprint, the carbon footprint of any deployment. It's optimized for resource use, its precision and security operations, the adaptive energy management the IoT devices bring, sustainable operations because everything runs together, everything's integrated, long time or long-term environmental benefits because of the energy reduction. And we talk about energy, we're talking about carbon, we're talking about electricity, we're talking about light, we're talking about air quality, we're talking about personnel going from point A to point B, wear and tear in vehicles. There's so many ways that this well-designed system impacts and reduces the cost of doing business, the cost of doing security, and really optimizes it. So just a quick recap. I mean, why not, right? AI-driven efficiency. When you add AI to the mix, AI is able to really determine and distinguish between what is a false positive and what you really need to be notified about. The AI box brings it to a whole nother level by being a self-contained device that you can put anywhere on the network and retrofit existing or new installations with more advanced analytics or with analytics in general. Decreased carbon footprint because of the lower power requirements from everything from the devices to your network, to personnel, to vehicles, to buildings. Resource conservation. On a whole, that's what you're doing. Everything brought together, reducing that carbon footprint becomes resource conservation instead of being over, requiring overly large amounts of power or uh, vehicles or just a waste of energy, a waste of materials. It lets you conserve all of it. CORTROL's comprehensive management between its various, and we didn't even really get a chance to touch upon this, but it has various ways of doing recording. We kind of touched on the fact that AI can be a trigger for when recording starts and stops, making recording more effective. There's scheduling that can work with AI and with the recording functionality. The lower storage requirements of CORTROL because it's not re-encoding the video. I mean, CORTROL in and of itself, you add AI to it, you add the IoT devices, you've got a platform that goes beyond security management. It goes into, well, sustainability management in a sense. MQTT and OPC are protocols utilized by the IoT devices that allow CORTROL to just get right into the mix with these devices and communicate with them and have them communicate with it. Data source management. Well, what's an IoT device but data? So CORTROL's ability to manage all that data and properly represent it in a fashion that is easily understandable. The video wall functionality that goes beyond video wall. You can do digital signage with the video wall functionality. You can create information in kiosks with it. You can create public display monitors with it. There's a lot that you can do. That's a whole lot of information. I'm sure it's going to take a while to digest it, but I'm sure this should have been a lot of questions that may have arisen from all that information. So we've got the time for a Q&A. If you are just too overwhelmed by any amount of information, you can always email me. So now's the best time to speak up, drop your questions, let's get some answers going. And worst case scenario, if you're just too overwhelmed by the amount of information, take your time, digest it. When you get the video recording from this, review it. Feel free to email and reach out, and we can always answer questions that come up at that point.